So in the previous presentation, I mentioned that would mock up an alternative to the fuel burning mechanic based on the balloons. So I'll do that very quickly, but I'm going to skip a few steps in that I already have a global variable created. So keep that in mind. It's called player fuel, and it already prints to screen. So basically all I'm going to do is burn that same fuel with the balloon. So whether we're burning with a rocket, so right now the rocket is the thing that's burning this this fuel, but I'm going to deactivate. I'm going to select my rocket and deactivate that. In the previous presentation, I had also locked the Playmaker editor window, which was just on this camera state machine, which was just an easy way to target some of the components. Again, that allows us to select different game objects and focus on the inspector without losing focus in the Playmaker editor. So I'm going to unlock that, and I'm going to reactivate my balloon. Now the difference with the balloon is that, remember, all of this stuff is happening in one state. So we have a get access vector, and we're adding force in the direction of the user input, and then we have a second add force, which is counteracting gravity. And by the way, I have two add force actions here, and that could get a little confusing. I mean, obviously, if I look at it, I can probably make sense of it, but there's a very helpful ability to add descriptions here. Now, this description might be appropriate for describing the state, but maybe I want to comment in between these actions to differentiate between the two add forces. And there's actually a comment action in here. If I search for comment, there's a debug category, which has some useful stuff in it. But I can just add a comment. And a comment is just a place where I can add some notes. And this comment, I'll move, try to move anyway. So I'm trying to get that comment to, there we go. The add force below is to counteract gravity. So now in a week or two, when I come back to this, I can say, oh yeah, really quickly, I don't have to decipher what this thing's doing, even though in this situation it's a pretty easy thing to figure out. I have this comment here, which will give me some quick advice or some quick orientation to what I was doing here. So this balloon mechanic, because we're not switching states, it's just a one-state state machine, we need to set up the ability to burn fuel. Now, there's a couple different ways that we can do this, but I just want to be able to switch states in order to do this. And we could do this as a separate manager, something that just tracks whether we're burning fuel or not. So again, I could set this up in a completely different state machine that's not adding force, that's not getting an access vector, but is just listening for input, specifically access input. So there's this ability for us to listen to input, which we're pretty familiar with at this point. But some of the options for input, if I can figure out, there it is, input. We can listen for an access event, and basically what we're doing is by default, this access event action listens to horizontal and vertical, and based on whether we're getting left, right, up, or down events, or any direction, which is what I'm most interested in, or no direction. So, are we getting input from one of these axes, or are we not getting any input from these axes? And we can use this action to switch back and forth between two different states. Okay, now in order to do this, I'll leave this action here before I mock this up. My current state is called player control, and I'm going to change this to player moving, and I'm going to right click and add a state and just call it idle. Okay, so now we have two different states. On the player moving state, we're capturing the get access vector, and we're translating that to add force and all the stuff that we did before. And on the idle state, we'll do nothing except we'll listen for an access event. Okay, and basically what I want to do is make a little loop back and forth between two states here. And I'm just going to right click and add a transition. I don't have any events set up, so I'll just build a nice, simple, generic next event for now. And whenever I build a two-state machine, I like to use just a generic action or transition name. So we just have a real simple loop built here that says next. And so on the player move state, basically in this state we're moving, right? We have player input. What we want to test for is at some point do we not have player input? So in other words, if we're listening to the horizontal and vertical axes, if there is no direction being applied, let's go next. So we'll pass it over to the idle state. And we'll do the same thing here. We'll listen for axis event. If we're in the idle state and we get horizontal and vertical input in any direction, let's go next. So in other words, if we're in the idle state and we have some horizontal or vertical input, we go to the player move state. And if we're in the player move state and our no direction, if the input is 0, then we'll go to the idle state. I'm going to right click on the idle state and I'm going to set this as the start state, even though it's not necessary because we'll start potentially with no player input and it should take us over to idle based on this axis event. And this should work. So I'm going to hit the play button and right now I have no input at all. Okay, and my player is falling. But the moment that I have player input, okay, I'm in player movement, okay, and you'll notice that when I let off, eventually it goes back to idle. Now, one of the glitches here is that in our player move, remember we're counteracting gravity, and we're not doing that in the idle state. So if we want that to be consistent, we'd probably need to copy this action. Oops, let's see if I can right-click and copy selected actions, and we'll just right-click over here and paste actions. Okay, so we got 2 different add force actions doing the exact same thing. This would be a great case to have a variable here instead of y, so that way if we need to change it, we don't have to change it on both states, we can just change the variable. But we now have this state switch, but we're still using the get axis vector. So I'm moving around, and basically what this is translating to is if I'm capturing user input, I'm in the player move state, and it's doing everything it needs to do. And if we're in the idle state, nothing's happening. And so now, in the player move, we can say, yeah, we're burning fuel, just like we did in the previous presentation. On the player move, we can come over here and do a float subtract, or a float add. Float add. And we'll add a negative value to player fuel. And just like before, we'll do, this time around I'll do -10. We'll do that every second, every frame. So when I hit the play button, now remember, the camera was printing the global value of fuel, and now that we're burning it in our balloon, every time we move, if I move up, it burns. If I move left and right, it burns. If we move down, it burns. So we're burning fuel by pushing this balloon around. Okay, so just kind of a different alternative to that burn fuel mechanic. And then of course, we'd want to test to see if we could run out of fuel or not. We don't have that mechanic set up on player move. And this really kind of gets to the point of making managers. We started to entertain this idea of making a player manager and a level manager. This player manager could manage whether we can move or not, and whether we have fuel or not. And then we don't necessarily have to replicate all the float compare stuff on each individual control setup. What we could do is we could have a fuel manager that says, okay, are we in a state where we're burning fuel or not? And we could have that handled by one FSM, and we could handle all of our movement in a separate FSM, and then that way as we change our setups or our player controls or our player objects, game objects, or we inherit new players or have multiple players, we can just scale up these mechanics really quickly and have, different managers looking at different things. Then we don't have to rebuild all that stuff inside each of our rigs. So keep that in mind as you start scaling up your game design concepts, and we get deeper and deeper into really focusing on the gameplay aspect and the mechanics that support that. So just a quick variation, and in the next presentation I'll jump back to the rocket and we'll do some review of some pickup refuel, and then we'll do just a real quick land to refuel. Okay, we'll do that in the next presentation.